Hello guys, in this video I'll try to explain you this problem and one algorithm we have. So the problem is this KOKO eating bananas. Never mind. So let me explain you what the problem says first. Yeah. Okay. So the problem says we have a array of pile sizes. So the pile size is 1, 4, 3, 2. What I mean by pile sizes is this first pile contains 1 banana, second pile contains 4 banana. Okay, and we have a monkey. He wants to eat all the bananas. So what we have to give is the speed at which he can eat the piles. So what I mean by speed is, so let's say speed is 4. So he can eat 4 bananas per hour. Okay, but the constraint here is, if let's say he starts with this pile, so he can eat 4 bananas. This pile only contain 1 banana, so he can easily eat this plus 3 banana from here. But if he starts from here, he cannot move to the next pile until this current hour ends. So in 1 hour he cannot move between 2 piles. Okay, so next pile he'll start in the next hour only. Current hour he cannot move to the next pile. So that's the constraint we have. So with the speed of 4, let's see how much time it takes him to end this pile. Okay, so for the first pile there's only 1 banana. He can eat 1 banana in 1 hour because his max speed is 4. So okay, so it will take him 1 hour. Then for next pile it will again take him 1 hour. So he can eat 4 banana in 1 hour. That's his speed. And then for third pile 1, and second last pile also 1. So total he took 4 hours. Okay, let's try with speed of 2. Okay, so for the first pile it will take him 1 hour. For second pile he will take 2 hours. Okay, yeah, because his speed is 2, so 2 hours from here. Then third pile again 2 hours, because 1 hour he eat 2 banana, then he's left with 1. Then he have to start his hour on this pile and he can't move between that hour to the next pile. So 2 hours, then again 1 hour, so total hour would be 6. Now let's take 1 hours, like let's take speed 1 banana per hour. So this pile will take him 1 hour, 4 hour, 3 hour, 2 hour, total of 10 hour. 4 3 7 7 3 10. Okay, 10 hours. But we are given h, this is the maximum hour we can take. So this exceeds that maximum hour, so this would not be our answer. This can be our answer, this can be the answer. But we want the minimum speed, so this would be our answer. So that's the question, and that's how we gonna solve it. So if you notice, what I did is, I took the maximum speed and the minimum speed. The answer lies between these two speed. So now I have to just test the different speed. I tested for 4, it was the answer, but it was not minimum. I can go even down. So then I tested 2 and it also worked. So then I tried more smaller value, which is 1. Then I tested 1, and 1 exceeds the r, so 2 was the minimum value I tested, which worked. So 2 is the answer. So if you see this is binary search pattern. If you see closely, because we started with 4, we ended with 1, and we tried all the numbers in between which are in sorted order. 4 is maximum, 1 is minimum, so we just have to choose one number and we can choose it using binary search. So for 4 we tested it was working, so we want lower number which will fall into this side of the not 4. Let's say we didn't test it 4 first. We took the mini midpoint, which is maybe, let's say 3 was the midpoint. We tested with 3 and it worked. Now we want more smaller value than 3, which would be on right side of the tree, because left side would be the greater value. Now we want more smaller value, so we'll go into the right side. Again we'll find the midpoint, which is 2, and we'll test with 2, it will work. So again we'll check on the right side, which would be 1, and it will not work, so 2 would be our answer. This was the last working value. So you see, this is binary search only. We just have to do a binary search and find the minimum number which works. So if you think this solution, then yeah, you're thinking in the right direction, you are correct. But the purpose of this video was not to show you this solution, but to show you an algorithm, uh, I think algorithm which finds the converging value, or I can say the border of value change. So if you see, I have this array. What this array contains is if the solution is valid or no, that value. So for example, with this 3 speed was a valid solution, no it was not, so it was false. This max speed is always a valid solution because that's the maximum speed. This is the minimum r it will take to end all the piles, which is always a solution. So this is 2, and in between these are some numbers for which the solutions are true, this which for which the solution is valid, and these are number for which solution is not valid, so I mark them as false. So if you see closely, the last true value, this last true value would be our minimum number for which our solution is valid. That's what we want. This is our answer, this number, whatever the number is here. So that is our number. So what we can do is we can write an algorithm which start the left pointer from here and right pointer from here. Then after algorithm ends, so let's say this is the converging line. After this line the value flips. So let's say after the algorithm ends, our left pointer value would be here and our right pointer would be here. So this is the final value of left and right pointer, and our solution would be the left pointer value. This would be our solution. And vice versa, if we want to find the greatest not valid solution, then right pointer would be the answer. Either way, but the main thing is this algorithm finds this converging point. So let me show you the algorithm, then I'll show you how it runs. Okay, now this is the algorithm. Leave this is just to check if the number which we picked is valid solution or not. This is what this function is doing. Leave this, focus on this while loop. So we'll run this loop until the left and right pointer cross each other, and whenever we have a valid solution we'll move right pointer, and when we have non-valid solution we'll move left pointer. So that's basically what this algorithm is doing. We can move left and right pointer one by one like this, like from here to here, then here, one by one, but it's more time consuming. So what we are doing is we are doing kind of binary search. We are finding the middle middle point to move the right pointer and left pointer. Why binary search is because if let's say this one is true, then the right side would be like the right side, all the values would be true only. So I don't have to check all the values of the, if let's say this is our middle point, if this was true, then I don't have to check all the values of the right, I can just check for the left. So that's what binary search is. So that's what we are doing. Okay, so this out of the way, now let me show you how the left and right pointer is moving according to this algorithm, so it will make more sense how this algorithm is running. Okay, okay, so this is the starting point for left right pointer. Let me copy more values. Okay, so right pointer starts here and left pointer starts here. Let's say in the middle of this while loop we came into a state where the middle point is this is the middle point. Now the middle point says the solution is false, so we'll move the left pointer, and the left pointer will move where, if you see, we'll move midpoint plus 1. So we now our new location of left pointer is this, which is actually the final position of left pointer according to the explanation I give you. So let's continue with the algorithm and see if left pointer will move or no, because according to algorithm left pointer reach its final position and it will not move now, but right pointer is here. So again we'll find the middle value. Let's say the middle value is here. This is the middle value. So whenever we get true value for the middle point solution, we will move right pointer. How? Like this. So we'll move right mid -1. Okay. So now the right pointer would come here. So actually the right pointer will keep on moving on the left where until the solution is true. For all the true solution, right pointer will keep on moving left. Now let's say right pointer by moving left, right pointer reach this point. Now you will see we get the solution. So once the left and right pointer are equal, now if you see the algorithm, it will run one more time because it's checked for left equals to right, and now the solution is true for the right. So again we'll move right pointer. So now the right pointer will come here. Now left and right pointer are crossed and while loop will exit, and this, you see, left pointer didn't even move and right pointer now reach its final position. And if we see, what we wanted was this number, right? This point, this index. So that's what we got it. That's what we got. Like, this is our answer. Or we can write right plus 1 also. That's also same thing. Right plus 1 is this only. Or we can write left. So that's what we are doing. This is the algorithm. Let me zoom in further. So this is the algorithm. We are returning left, or we can return right plus left, whatever. So yeah, I hope you like this video and explanation and it makes sense. And if you like the video, hit the thumbs up button. If you don't like the video, subscribe the video. Maybe next video you will like. So see you. Bye bye.